Okay. So I have to do everything today, and he'll just be sitting there. Yep. Alrighty. That's me. Good morning. I've been in networking for something like 40 years, literally. I started at 16 or something, so now you know how old I am. I hope I look younger, but whatever. Anyway, I was also doing a number of other things, from writing device drivers for the operating systems, to writing my own sort of a database, to writing my own programming language, to programming websites. And I'm still punished for that because I have to explain to the youngsters what the joins are in SQL databases and why you need indices on databases and stuff like that. But majority of the time I was spent on networking, starting with the early TCP/IP, and then I was there when we did migration from BGP3 to BGP4 in early 90s, I think. I was running the first ISP business in my country. So if anyone was watching these old movies where people dial in and there's this weird sound on the modem, we were doing that. For the last 20 years, I was more or less explaining people why things don't work the way the vendors advertise things work. And that made me old and cynical. And you might notice some of that in what I'll be telling you today. Anyway, my personal history of network automation. I was running an ISP business in the 90s, and we had the dial-up customers, and because there was no authentication system at that time, we had to enter the username and the password of every customer on every device that the customer could dial in. And that was a nightmare. So we wrote this little Perl script that would look into the CSV file that was exported from a Microsoft Access database, and it would generate the configuration, and it would push it to all the devices using R shell, if anyone knows what that is. That's like SSH but not encrypted, because SSH didn't exist at that time. This is so old that SSH didn't exist. And we had a fully automated operation, and then we added the static routes for the leased line customers and routing and all the other things. So we had a full-blown, fully automated ISP operation in 1995. And we weren't the only ones. There were a lot of people at that time who realized that, oh my, I don't want to do this by hand because it's boring, and they wrote some scripts. And you know, today everyone is talking about Yang and data models and this and that and that and that. Guess what? Juniper had that in 1997. And people who were using the Juniper boxes were pretty happy with that, and in 2000, Juniper made that public, and then obviously the customers started pushing that, you know, this should be standardized. It took them only 6 years to standardize the transport layer, the netconf. It took them another 6 years to standardize the language that defines the data models. And it took them another 10 years to define the first data models. So things move slowly when you're not interested in moving them, because all the other vendors just weren't interested in this. Because, you know, this would give Juniper some advantage because they already had the stuff for 10 years. That's how this industry works, and that's one of the things that makes me cynical. Anyway, in 2011, a few academics discovered that they would really love to test their stuff. And everyone is telling them that, you know, if you do stuff on the virtual machines in your laptop, that is not real world. So they said, well, we want to have some mechanism where we could program the actual hardware because, you know, people are telling us that's fun. So they created this thing called OpenFlow, if anyone has ever heard about it. Turns out that OpenFlow is a total failure because, you know, you can't just take the brains out of a person and put them on the other side of the classroom and expect that person to keep walking. That doesn't work. But, you know, no one wants to listen to people with practical objections, so OpenFlow was a huge buzz. And at that time, the venture capitalists had this problem that they had nowhere to invest the money. There was no fancy new technology. There was no AI at that time. So they took OpenFlow and SDN and created this huge hype out of that. That resulted in one of the startups being acquired for $1 billion. Not bad for a hype bubble. Anyway, in those days, we were in the OpenFlow is the answer. What was the question bubble? Now, obviously, no vendor was interested in doing that because that would effectively take their crown jewels away. Everyone is claiming that the vendors are, you know, selling boxes. No, they're selling hardware because they have to. The software is the crown jewels. But they can't sell software. They're not Oracle or Microsoft. So they're selling boxes. And now someone wants to take the crown jewels away? Well, this will not fly. But, you know, people are asking for SDN, so let's try to, you know, rebrand that. So SDN is really APIs and automation, and you don't need OpenFlow. That was the second wave of the hype, and during that wave, Yang was launched. And we got to the point where people were saying, well, you don't need SDN, you have Yang. Excuse me? It's like I don't need literature because now I can use English instead of French. How does that make sense? Anyway, we got past Yang is the answer, what was the question moment, and I'll refer to Yang a little bit later. Anyway, another thing happened in 2012. A smart person created this tiny little tool that was supposed to be used to provision Linux software, and he called it Ansible. Did anyone read Ender's Game? There was also a movie, a sci-fi novel. Great, bonus points. A sci-fi novel where they have this faster than light communication mechanism. It's called Ansible. And this is, well, it was also used in some other prior sci-fi novel. Anyway, this is why this tool was called Ansible. Now you know where the name is coming from. That tool is great if you're doing small things. And was simple at that time. Today is bloatware. And then someone discovered that you could write your own modules, and they wanted to automate configuration deployment on network devices, and they wrote the modules themselves. The modules were crap, but they worked. And so we got to the stage where Ansible is the answer. What was the question? And we are still at that point today. People are still using Ansible. In 2020, I said everything I had to say about network automation, and I will not talk about it anymore. It's boring. It's a done deal. Everything I had to say, I said, and I stopped. And this year, there was this network automation forum, the first one. Actually, someone just needed an excuse to have a new event. And they are in the network automation space, and so they created the network automation forum, because forum sounds so much better than event. And in that first event, they were discussing things that I was writing about a decade ago. I was like, oh shit, nothing changed in the meantime. So here we are in 2024, and not much has changed since 1995. Now you can go home. Anyway, what I'll talk about today is, first was the difference between automation and orchestration. Then something really interesting for me, the hierarchy of network needs, and I'll tell you how you should structure your automation efforts. And then, if we still have time and you won't all run away in disgust, then we can talk about what's hindering us today. And then, for people who still won't want to give up, although it's Friday, and it will be Friday afternoon by that time, I can tell you how to start a typical automation project, and then I'm here for however long you want me to be here. As long as there's beer on the table, we can have discussions. We have the room for 3 hours, you told me? Okay. So, totally up to you. But I understand if you run away after 45 minutes. Okay, first automation and orchestration, because people are talking about both today. I got this great explanation that, you know, whenever you have something that is repeatable, and you write a piece of software, or you build a robot, or you do whatever that does it on its own, that's automation. So automation is eliminating repeatable tasks. So you don't have to do them yourselves. But usually these are small tasks, and better this way? Okay. And they have to be somehow collected together in a sequence. So if you're provisioning a new device, you cannot configure the device before the software is on the device. And you cannot configure the device before you know the physical address of the device. And you cannot log into the device before it's configured. So you have to string these things in sequence in some sort of logical workflow with some if then else in the mean, somewhere in the middle, and that's orchestration. So automation is eliminating manual tasks, doing them by software or hardware, and orchestration is stringing the whole thing together to achieve whatever your goal is. But this is the terminology and semantics, and people are using one or the other depending on which marketing department you work in. So you will see them used interchangeably. Now, if you want to automate something, it better be repeatable, because if it's not repeatable, you cannot describe it. And you have to describe it to the level where a moron called the CPU can execute it. So that's the usual problem in network automation, because you just don't know enough about what you're doing to describe all the tiny little details of what needs to be done. Because when you sit at the keyboard and you type in, like 80% of the stuff that you're doing, you're just taking for granted. Oh, I log in. Okay, how do you log in? Well, I open the SSH session and I log in. Okay, I get the SSH session, but how do you log in? What do you mean, how do you log in? What? How do you log in? Oh, yeah, okay. I wait for the username prompt, and then I type in something, and then I wait for the password prompt, and then I type in something, and okay, how do you know that you typed in the right thing? Oh, it's echoed back to me. Okay, I can live with that. And then you write that, and then it doesn't work, because the password is not echoed back to you. So it's the tiny little things that we don't even think about that trip us when automating stuff. So this was some sort of a made-up example, because you could say, well, I'm using SSH keys, get lost. And you would be right to say that, but you get the idea. There are the tons of little details that we have to define if we want something to be automated. And it better be repeatable, because, you know, if you invest a lot of time into automating something that is only done once, then congratulations, you boosted your CV, but you just wasted time. Okay, so you get 100 networking engineers in the room, and you say, well, now we want to automate our networks. What do you think should be automated? And like 95 of them would say device configurations. This is the only thing they can think about. What are you doing your whole day? Well, I'm logging into the boxes, I'm typing in the device configurations, I want to automate that. Anything else? No, that's what I'm doing, I want to automate that. And majority of automation projects stop at, let's automate the device configuration. That's so boring. It's only like day one activity. This is what you do when you build the network. And then you have to be running the network for the rest of your life, and you don't want to automate that? How stupid is that? So configuration, device configuration is like the major answer you would get from any network automation forum. Device provisioning is another interesting one. So you plug in the device and the device wakes up and it sends a DHCP request. Give me an IP address, and then you can capture that and figure out where it came from and figure out to what this device is connected. And then you give it some IP address and some initial configuration. And then you log into the device and you do some discovery. And you figure out what all the links are connected to. And then you build the custom configuration for that device and you push it down to the device and you have a fully operational device. People are doing that. It's relatively easy, but you know, if you would ask networking engineers, they wouldn't mention it. It's not on their radar because someone else is doing the power up. And then there are the access control lists and the firewall rules, because this is the really boring stuff and we really want to automate that. And people usually don't mention things like troubleshooting. You can automate troubleshooting. So for example, you are in a big organization and you get like 20 phone calls, well, trouble tickets per day saying my phone is not working. And then you always do the same thing. What's your phone number? Where was the MAC address of this phone? Where's the phone connected to? How is that port configured? How is the uplink of that switch configured? Are you sure you're in the right VLAN? So you're doing like 10 steps trying to identify the problem, and you're doing that 10 times a day. And you don't want to automate that? There's a huge opportunity in automating troubleshooting, and people are just not doing it. Well, some people are. There is this open source project where a bunch of service providers got together and created a website that troubleshoots IPv6 connectivity. So, and you can do it, you do it in a browser. So effectively, they try to open a website that is IPv6 only, and they try to resolve names that resolve into IPv6 only addresses, and they try to resolve domains that are only resolvable over IPv6. So they have tons of different tests, and every test can fail. And they combine all that and give the customer a single 2-letter code. And the customer then tells the help desk what the code is, and they wrote a manual for the help desk. If you get this code on Windows, then you have to tell the customer to do this. If you get this code on Mac, then you have to tell the customer to do this. So they totally automated troubleshooting IPv6 connectivity for the service providers. So it can be done. Oh, another one, consistency checks. Are all ports configured the same way? So for example, you don't want to be running, let's say, routing protocols with your Windows laptops, right? So there's a way to stop that. But have you applied that filter to all the ports? Have you applied it to all the ports toward all the wireless access points? How do you know that? Well, it's very simple. You log to all 1,000 devices in your network, you do some show commands, you look at the results. Now, how long is that going to take? Of course, you automate that. Oh, the best story I've heard about automating, you know, stupid stuff. A large campus had a power outage. and they had thousands of switches, and all switches were on UPS. But you know, UPSs have batteries, and the batteries fail eventually, and if the batteries are too old, they don't last for 4 hours, they maybe last for 2 hours, like your iPhone. And so the power outage was long enough that some switches failed, while UPSs failed. And so the question was, well, can you identify which UPSs we have to replace? Well, it's very easy. You log into all 1,000 switches, you look at the uptime. If the uptime is longer than when the outage was, obviously it survived. If the uptime is lower, we probably have a problem. You have to log into 1,000 switches. And you have to write a report. And obviously, well, it's boring and you will make errors. So someone made that his first project on the my automation course. Was like, dude, you totally nailed it. That's exactly what you could do as a first automation project. It's simple, it's well-defined, it's read-only, you're not changing anything, and it gives you extremely valuable results. Then, you know, if you really want to go into complex stuff, you could change the way the traffic is forwarded in your network. And some people are doing that. So for example, you know that the optical guys will do maintenance on some fiber cables that connect CTA to CTB. Let's say direct to burn. And you know that these guys are unpredictable, and the optical cable will be disconnected like 3 times within an hour, and you really don't want the link to go up and down and up and down and up and down, and the traffic to be sent here and there and here and there. So you say, well, you know what? I'll shut down the link in advance, and then when they tell me they are done, I will not enable the link immediately. I will turn it on, but not send any traffic on it, and then I will run tests on it. And when my tests say the link is okay, then I will start sending the user traffic on it. Obviously, you could have a rule book, like 5 pages of instructions, how you can do that manually. Or you could automate that. Smart people are automating stuff like that. Anyway, now that you know what can be automated, let's go through how we could do stuff and what makes sense. I stole this from a good friend of mine, and it's like, you know, the pyramid, Maslow's pyramid of needs? Okay, I never got that name right. So he said, well, you know, first you need a functioning network. If you don't need to have a functioning network, don't spend time on automation, you have a bigger problem. But when you have a functioning network, you have to run it, operated network. Then maybe we should talk about abstraction of the network state, and I'll tell you what I think about that. And then we can start talking about automated provisioning and finally the automated remediation. So something bad happens and I automatically change something so that network keeps running. We'll skip the first part, we'll go to the operated network. And this is how we run networks today. People think of networks not as distributed systems, which you should be doing. After all, you know, you will be finishing a university, so you should have slightly bigger picture in mind. People think about networks as boxes that have to be configured. That's a totally wrong approach. That's what needs to be done at the end, but you really should be thinking about the system. And obviously, there is some high-level definition of, oh, we need to connect this site with this site, and we have a campus network here with 1,000 users, and we have the data center here with 100 servers. And someone has to translate those requirements into the devices and configurations. And it's usually that guy over there with a whiteboard looking like that one. And the translation is done in his head. that's the state of network design in most enterprise organizations today. Oh, they have Visio diagrams, and no one is ever updating them. So if someone ever shows you a Visio diagram, it's like almost 100% sure that it's out of date. Which brings me to another cool project one of my students made. Multicast is a huge pain to troubleshoot. And so he logged into all of the devices and collected the multicast information on all the devices. And then he wrote a Python program that turned that into a dot file. Has anyone used that open source graphing tool? It's GraphWiz, right? So you define the graph in a text file, and then that tool generates JPEG or PNG or PDF or whatever out of that definition. So he used that and he created a huge diagram of how multicast looks in their network. I think he was working for some financial institution. They use multicast for stock feeds, because the same information has to be present on all the workstations at the same time. And he said, well, you know, whenever we get a report that multicast is not working, we run this tool first. We don't start troubleshooting. We wait for the 15 minutes for the tool to collect the information. And then we are so much quicker resolving the problem because we know how the network looks like today. Anyway, because we have this unreliable guy in the middle, you're not allowed to make changes during the day. Because we all know that that guy is not reliable. And also, he's typing the changes in with his keyboard. And he's doing copy-paste, and sometimes he does copy-paste in the wrong window. Or he reloads the wrong box in the wrong window because he got a phone call in the middle and then he just pressed enter in the wrong SSH session. Guilty, happened to me. So I'm that guy. Anyway, because of that, you're not allowed to change anything during the business hours. You always have to document in advance what you have to do, and then someone will review the changes, and then you will schedule the maintenance window that is Sunday 2 a.m. because at that time we hope no one is working. And then you get into the office at 2 a.m. on Sunday, and of course you didn't drink enough coffee and you make mistakes. And then it's 5 a.m. on Sunday morning and the network is still broken, and then you have to decide what to do. Will you push forward and hope that you will get it done by 6 a.m. when the network should start working? Or do you roll back and give up and schedule the change for the next weekend? Now, guess what every decent networking engineer does? I can make this work. And this is how you get to the front page of the national newspaper. And yes, I've been there. Wasn't me personally, but it was one of my engineers, and I felt the pain. They did a perfect migration project, and then they hit a bug when they did the migration, and in panic they upgraded to the latest software release, which contained another bug. And that bug was triggered only under high load. So all their tests were running just fine, and then on Monday morning, when the users actually started using, this was the biggest ISP network in the country, the core switch collapsed. And we made the front page. Anyway, immediately what you should do is you should start collecting the configurations of the devices, store them somewhere, and keep track of the changes. So that if nothing else, when someone claims that something stopped working and you ask, well, what has changed? And they tell you nothing, which happens all the time. at least you have a history of changes. You can prove to them it was not nothing. Which, by the way, in networking we call the mean time to innocence. Is the time it takes to prove that the network is not the problem. Because, for example, there's lack of paper in the printer. Anyway, if you want to collect network configurations, there are two great open source tools, Rancid and Oxidized. Oxidized is newer, so I would start with that one. And if you want to use version control, there is only one tool that I would recommend today, and that's Git. So eventually you will have to use Git. Get used to it. Don't fight it. So this is how we would usually do stuff in large organizations. So you propose the changes, someone reviews and approves them, then you schedule the maintenance window, then you try to do it. Immediately, what we can add to this process is collect the device configurations after you're done, store them into the repository so that you have a history of changes. That's the absolute minimum that everyone should be doing these days, and people are still not doing it. You wouldn't believe how many organizations have no idea what's changed in their network. Oh, and then we have the beautiful products like VMware and all the cloud providers. They don't have configuration files. You want to ask someone, how is your VMware system configured? It's all through GUI. They also have APIs, so if you write your own extractor that collects information from 100 API endpoints and writes a report, you can do that. And then you put that report under the source control, and then you know what the changes are. But the vendor does not provide that. Same thing with all the cloud providers. They all have the API, you use the API, you provision stuff. What has changed? We don't know. You provisioned your stuff. You should know. So we don't know how happy we are that the network devices actually have text configurations. Anyway, if we're using Git, then, you know, let's use it for real. So they were all using Git, right? Good. So you know what I'm talking about. Create your own branch, make the changes in your own branch, submit the push request, pull request, whatever it's called, merge request. Someone can review that. Then you have the proposed new configurations. Then you deploy them on the physical device. You check whether it works or not. If it doesn't, you roll back. It's easy because you have all the history. If it works, you merge the configurations into the master branch, and this becomes the official new configuration. And because we need cool names if we want to appear with a presentation on a network automation forum, we call this GitOps, or operations with Git. And if you want to sound even cooler, then it's NetGitOps. Because what's better than, you know, the German way of taking 3 words and putting them together into 1 word? But because this is English, we have to shorten them. So it's NetGitOps, and you'll sound cool. Anyway, this is probably the most important part of what I'm talking about today. You shouldn't be thinking about devices and device configurations. You should be thinking about what you want to achieve. And because what you want to achieve is called intent in English, let me introduce you to another buzzword, which is intent-based networking, which is just a whole pile of bullshit. And I'll show you what's behind the scenes. So on the left-hand side, you have a typical network device configuration. This is taken from Cisco IOS. And if you look at 15 device configurations from your network, they would all be the same apart from 1 or 2 changes. It's just that, you know, because all networks are different because, you know, they all route IP, So they have to be different, right? All the networks are different, and so every network operator wants to configure his devices in a slightly different way. So every vendor gives you like a gazillion nerd knobs to turn, so that you could fine-tune your devices in just the way you want them to work, and raise support costs for everyone, but that's beyond the point. Anyway, that's why we have such a long list of commands just to get to a point where it says, well, I have a loopback interface and I have an Ethernet interface, and these are the IP addresses. But those 2 bits are the only important bits in the whole thing. That's the only difference between this device and that device, because everything else is the same. So really, you can abstract all that into, dude, I have a device, it's called R2, it has loopback, and the loopback has IP address 10.0.1.5, and it has a LAN interface. And because different devices call it Ethernet port under different names, sometimes it's Ethernet, sometimes it's fast Ethernet, sometimes it's gigabit Ethernet, and then you have some devices that have ports that are called 10 gigabit Ethernet, because it's so nice to type long strings, right? Instead of that, I just have a LAN interface. Come on, it's connected to a local area network. What do I care about the interface name? But the device does, so I have to specify it, and I give it an IP address, and that's it. So I already went from, a lot of nonsense to what really matters. And if you get to that point, it's good. Congratulations. You made your operations simpler. But there is a huge elephant still in this room. Namely, you usually have more than one device connected to one link. Otherwise, you don't have a network. And all devices on the same link has to be in the same IP subnet. So if you use this approach, then you will specify the same subnet in 10 different places. Guess how many times you will make a typo? And if you want to change the subnet, guess in how many places you have to make the change. Did you guys already discuss databases? You had that already? So, the problem of the third normal form. Remove all the duplicates. We have to do the same thing here with our data model. Or, as a friend of mine says, duplicate data makes rockets explode. It wasn't actually duplicate data, it was duplicate code. When they were creating the software for the Ariane 5 rocket, I think, they took the code from Ariane 4 and copied it over. And they got an integer overflow because the sensors on Ariane 5 were more sensitive and generated larger numbers. And the software got totally confused and said, abort, 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 and the rocket exploded in midair. Perfectly fine rocket working quite correctly with a software bug. That was caused by copy-paste, so never copy-paste. Anyway, what we really want is, instead of specifying a device, we should specify how the network looks like. In this case, I'm running BGP because, I just had that example handy. I have 2 nodes, they have different autonomous systems. They are linked with one link, and that link has this subnet and 2 nodes connected to it with the interface names. If anyone wants to know more, I wrote a whole series of articles on that under this URL, where I walk you slowly from the starting point, the device configurations, to the endpoint, the network data model. So you'll see all the interim points. And by the way, this is like the hardest thing that people in my automation course had to go through. because one of the tasks was design the data model for your network. And the comments I got was like, dude, this was the hardest thing I had to do in years. You think you got it, and then you start thinking about it and you realize it's totally wrong, and you have to go back to the drawing board and redesign the whole thing, and you do it like 5 times and then it looks perfect. Anyway, if we do something like that, we effectively remove that guy from the picture. Which means that we need some software in the middle. You know, between the desired network state and desired device state, there has to be some magic in there. Not AI. Don't get me started on AI. There has to be some magic in there that transforms the network state into device state. And then we add the configuration templates for the devices, and then you get the actual configurations and you push them out. But that knowledge is now encoded in the source code. It's no longer in the brains of that person, which makes it consistently wrong. That engineer is making random errors. Your Python code is making repeatable errors, which means that once you catch the error and you fix it, it's gone for good. Whereas that guy will type reload in the wrong window tomorrow as well. Okay, so instead of the brain mapping, we now have the explicit mapping. If you do it right, then you separate the services, what connectivity I'm providing to the users, from the core network, the links and the nodes. You can simplify the deployment of devices from different vendors, because obviously they use different configuration mechanisms. But because you are thinking about the network, not devices, it's now easy. Oh, I want a different vendor. Okay, I will just add new translation code. I will add new configuration templates, but my network definition stays the same. Okay? Configuration compliance is easier because you know what to expect. Previously, you were thinking about boxes. If I would ask you which boxes are connected together, you would have to say, okay, let me look at the subnets, and if the devices are in the same subnet, then I assume they're connected. Well, that works well until you have duplicate subnets in your network, which cause all sorts of other problems, but that's a different story. Anyway, now we can easily validate that things are wired correctly, that things are configured correctly, that things work correctly. It's easy to identify mismatches. It's easy to figure out whether someone was messing with the configuration manually. And it's easier to change the device configurations consistently. You change the template, you test the change, you approve the change, and then you deploy the change on all the devices. Which brings me to automated provisioning. And this is like the holy grail that a lot of people are talking about. You have to go there if you're big enough. If you're so big that you can't do things manually, then this is the only way. That's why all the big service providers are using this. This is why all the big cloud providers have everything automated. Once you get to this point, then you can start offering self-service so that the users can configure their stuff themselves, that you don't have to get involved, which means that the service deployment is faster because there is no human involvement anymore. It's like, when you work with AWS, you click there, the credit card is charged, you get the VM. And you absolutely need this if you want your operations to become more reliable. Because with humans typing in, it cannot be reliable. Obviously, if you want to do this, then first you have to know what you want to do. You have to standardize the services. And that's the biggest showstopper in today's organizations. They simply can't define what they're doing, because everything is an exception. And then you have to have a reliable method of configuring and monitoring the devices, and I'll get to that, and it's a nightmare. Tools that people are using today. A lot of people are running their networks on text files. Is this telling me I'm out of time? Sort of. But I wanted to get through the first part in, you know, the 45 minutes. I'm not Swiss, I apologize for that. Anyway, people are still storing their network definitions in YAML files, and if you're small enough, that's okay. Then people grow and they say, well, I will use some tool like Netbox or Notobot or whatever. The problem is that those tools work at pretty low level. They will manage your subnets, they will manage your devices, they will manage your VLANs maybe, but nothing higher up, the higher levels of abstraction. So either you adapt your workflow to those tools, or you write extensions for the tools, or you just give up and you define you create your own application, and then you have to maintain it indefinitely. Which is, on the other hand, job security, so don't complain. Ansible is often used for the automation framework. So if you want to deploy 5 different things on devices from 3 different vendors, then you take Ansible. If you want to do data transformation, if you want to do, you know, going from the network device data model to the device data model, Ansible is not a tool for you. Use Python. Eventually, everyone ends writing their own provisioning app because everything else sucks. And now we are in the unicorn land. And if you see the shade of blue on this slide, I know you know why I'm saying we are in the unicorn land. These are the things that the really big guys are doing, because no one else has the manpower or the knowledge or the time to do it. These are the things like, let me look at the optical counters on all my devices and figure out where the fiber optic cables are failing, and figure out whether I have a backup path, and if I do, take the link out of the operation and automatically open a ticket with the provider of the fiber optic cable that his cable is failing. Or it's the stuff like, oh, I'm monitoring memory on my devices and they're consistently leaking memory, and I open the bug report with the vendor, but it takes them 6 months to fix it. So what am I gonna do in the meantime? Okay, I'll monitor all my devices, and if the RAM usage exceeds a certain number, I will carefully take the device out of operation, and then I will look around to make sure that no one is using it, and then I will reload the device, and then I will make sure the device is operational, and then I will slowly let traffic back onto the device. This is even more complex than what I described here, but Facebook is doing that. Anyone wants to know more details? These guys had a nice presentation on a RIPE meeting. There's a video there. Keep in mind that that stuff is 10 years old. Who knows where they are today? Well, we know that today they are so automated that they managed to log themselves out of their network. They bricked one of the core routers, and because the edge nodes deployed throughout the world couldn't get back to the data centers, the edge nodes stopped replying to the DNS requests, so the whole Facebook domain went down. And because they're using single sign-on with their Facebook account to get onto the devices, they couldn't log into their own devices. And because they use single sign-on with facebook.com domain with Zoom, they couldn't even schedule the video conferencing calls to discuss stuff. In the end, there was supposedly some hardware involved to remove a lock to get into the device to power cycle it. Anyway, this stuff is really hard, so don't expect a vendor to solve it for you. You will have to do it yourself, and it's really, really, really hard. It's just starting with what is an event is a hard question. So a link goes down and the link comes back up after a second. Is this an event I should act on or not? Who knows? If it happens 10 times per day, yes, I should. What if it happens once per week? So, just defining what to act on is hard. And then you could say, well, I will take this link out of operation and, you know, report the error. But do you have a backup link? Is taking this link out of operation making things better or worse? And AI will not help you. And the answer is different for every network, so you will have to do a lot of things yourself. And the only way to get things done is you start small, you use small reusable components, and then you slowly build them together into a larger system. And the last message, don't care about terminology. People are talking about network automation, people are talking about SDN, network programmability. Who cares? What's really important is that you abstract the state, that you centralize things so that you have visibility. You might think about feedback loops, you might think about proactive behavior, but that's hard. And finally, as I told you, you can automate anything that is repeatable, including troubleshooting. Last thing, and then we can make a short break. Shit happens. When shit is automated, it happens on scale. Bank in one of large European countries automated software upgrades on routers at the branch offices. And once someone made a mistake, and instead of sending the file with the software, they sent with the file with the MD5 checksum for the software. And because they believed in the process and they had no safeguards, they didn't check the file size or anything, and the process upgraded all routers at once without checking if the first upgrade failed or not. So they bricked a few hundred routers. And then they were visiting every branch office for the next few days and doing software recovery manually. So, yes, shit happens. Okay. Any questions so far? So what the strategy now is for me to be quiet until someone gets nervous and asks a question, right? I can be quiet. Yeah, it worked.